Welcome to the Punchline Podcast. I'm Punch, your guide through the integration of aerospace and automotive mobility. In our previous episodes, we explored the foundational concepts of IAAM and the propulsion technologies that will power this transportation revolution. Today, we shift our perspective upward and outward to examine how our cities themselves will transform to accommodate three-dimensional mobility networks. The implementation of integrated air and ground transportation isn't merely a technological challenge. It's an urban planning revolution. Our cities have evolved over centuries primarily along horizontal planes, with vertical development limited to buildings rather than transportation corridors. As we begin integrating aerial mobility into daily life, urban landscapes must adapt in unprecedented ways. Joining me today are three distinguished urban planning experts from cities at the forefront of preparing for integrated mobility. Each brings a unique perspective shaped by their city's geography, history, and vision for the future. Together, we'll explore how different urban environments are approaching the three-dimensional mobility revolution. Let me introduce our guests. First, Dr. Lin Mei Hua, Chief Urban Transformation Officer for Singapore's Urban Redevelopment Authority, where she leads the city-state's Sky City 2035 initiative. Dr. Lin, welcome to the Punchline.
Thank you for having me, Punch. Excited to share Singapore's vision with your listeners.
Next, we have Carlos Ramirez, Director of the Los Angeles Department of City Planning's Future Mobility Division, where he's developing the framework for what LA calls its Elevated Corridor Network. Carlos, thanks for joining us.
Great to be here. Los Angeles has been dreaming about flying cars since the 1950s. Now we're finally planning for the real thing.
And finally, we're joined by Dr. Elizabeth Harrington, Head of Three-Dimensional Infrastructure Planning at Transport for London and advisor to the Historic Urban Centre's Adaptation Commission. Dr. Harrington, welcome.
Thank you, Punch. London has been reinventing itself for 2 millennia. This is just our latest evolution.
Each of your cities presents unique challenges for integrating aerial mobility. Dr. Lin, Singapore is often cited as the ideal testbed for new transportation technologies. What makes your city-state particularly well-suited for early IAAM adoption?
There are several factors that position Singapore advantageously. First, we have a centralized urban planning approach that allows for coordinated, whole-of-government decision-making. When we commit to a new direction, we can align regulatory frameworks, infrastructure development, and public engagement simultaneously. Second, our compact geography, just 728 square kilometres, creates both necessity and opportunity. We simply don't have the luxury of expanding outward, so we've always been forced to think three-dimensionally. Our people are accustomed to vertical living and transportation solutions, like our automated MRT system. Third, we have an established technology ecosystem and regulatory sandbox approach that allows for controlled experimentation. We've already designated 7 aerial mobility zones, where we're testing not just the vehicles, but the entire supporting infrastructure and digital systems.
Carlos, Los Angeles presents almost the opposite challenge, a vast, sprawling metropolis built around the automobile. How is LA approaching this transition?
You're absolutely right about LA's car-centric development. We have over 7,500 miles of public roads and nearly 6 million registered vehicles in the county. Our challenge isn't density, it's distribution and distance. Our approach leverages what might seem like a disadvantage: our sprawl. We're identifying what we call mobility nodes, typically existing transportation hubs, large shopping centers, and key employment centers, where we can establish initial vertiports. These nodes are already commercial centers with substantial parking infrastructure that can be partially repurposed. We're also utilizing our extensive network of helicopter landing facilities. LA has more heliports than any other U.S. city due to our film industry, news coverage, and emergency services. These existing facilities provide an initial framework to build upon. But perhaps most importantly, we're reimagining our transportation corridors. Our freeways, which currently divide communities, can become multimodal corridors with aerial transit running above them. This approach minimizes new disruption while maximizing the utility of land already dedicated to transportation.
Fascinating approach, Carlos. Dr. Harrington, London presents yet another distinct challenge, a densely populated city with historical infrastructure dating back centuries. How does a city with Roman foundations prepare for aerial mobility?
That's precisely what makes London such an interesting case study. We're essentially layering 21st century mobility onto a street network with medieval origins. The average street in central London is narrower than what you'd find in planned cities like Singapore or even the newer parts of Los Angeles. Our approach is threefold. First, we're identifying what we call transition peripheries, areas just outside the historic core where we can establish major vertiports. These are typically former industrial zones undergoing regeneration, like the Royal Docks or areas around Battersea. Second, we're developing what we call heritage-sensitive integration points, smaller transition facilities incorporated into existing transportation hubs like rail stations, where passengers can move between ground and air transport with minimal impact on historic structures. Third, we're establishing digital routing protocols that create virtual no-fly or reduced speed zones over historically sensitive areas, key viewsheds, and residential neighbourhoods. This ensures that aerial vehicles navigate London in ways that respect both its physical and cultural landscape. I should add that we're also seeing opportunities to reduce ground-level transportation infrastructure in some areas, potentially returning streets to pedestrians as more traffic moves to the air.
All three approaches demonstrate how different urban contexts require tailored strategies. Let's turn to regulatory frameworks. Carlos, Los Angeles operates within the complex U.S. regulatory environment. How are you navigating FAA regulations alongside local zoning and planning requirements?
That's precisely what makes London such an interesting case study. We're essentially layering 21st century mobility onto a street network with medieval origins. The average street in central London is narrower than what you'd find in planned cities like Singapore or even the newer parts of Los Angeles. Our approach is threefold. First, we're identifying what we call transition peripheries, areas just outside the historic core where we can establish major vertiports. These are typically former industrial zones undergoing regeneration, like the Royal Docks or areas around Battersea. Second, we're developing what we call heritage-sensitive integration points, smaller transition facilities incorporated into existing transportation hubs like rail stations, where passengers can move between ground and air transport with minimal impact on historic structures. Third, we're establishing digital routing protocols that create virtual no-fly or reduced speed zones over historically sensitive areas, key viewsheds, and residential neighbourhoods. This ensures that aerial vehicles navigate London in ways that respect both its physical and cultural landscape. I should add that we're also seeing opportunities to reduce ground-level transportation infrastructure in some areas, potentially returning streets to pedestrians as more traffic moves to the air.
All three approaches demonstrate how different urban contexts require tailored strategies. Let's turn to regulatory frameworks. Carlos, Los Angeles operates within the complex U.S. regulatory environment. How are you navigating FAA regulations alongside local zoning and planning requirements?
It's definitely complex. Unlike our colleagues in Singapore, we don't have a centralized decision-making process. We're coordinating between city departments, LA County, neighboring municipalities, state agencies, and federal regulators like the FAA. We've established what we call the Southern California Aerial Mobility Collaborative, a working group that brings together all these stakeholders. This group is developing a standardized approval process for vertiport locations and operational parameters that satisfies requirements at all levels. One breakthrough has been the development of graduated regulatory zones that align airspace classifications with ground level zoning. For example, areas zoned for industrial use typically have fewer noise restrictions and may allow for 24-hour aerial operations, while residential zones have stricter limitations. The FAA has been surprisingly adaptive, creating a new urban air mobility division that works directly with cities. They recognize that traditional airport-centric regulations don't apply well to distributed aerial mobility networks.
Dr. Lin, Singapore's regulatory structure is quite different. How has that influenced your implementation?
Our advantage is indeed regulatory integration. The Civil Aviation Authority of Singapore, Land Transport Authority, and Urban Redevelopment Authority operate under coordinated ministerial oversight, allowing us to develop unified regulations. We've created what we call integrated mobility zones with tiered regulatory frameworks. Each tier has specific requirements for vehicle certification, operator licensing, noise limits, hours of operation, and passenger screening protocols. However, we recognize we can't simply mandate this transformation. Public acceptance is crucial. We've implemented a community consultation program called Sky Neighbours, where residents in areas designated for vertiports can participate in the planning process, test simulated noise levels, and experience mock journeys. This approach has revealed interesting insights. For instance, residents are often more concerned about privacy than noise. This led us to implement mandatory visual screening protocols in aerial vehicles flying below certain altitudes in residential areas.
Dr. Harrington, London has additional complexity with its historic preservation requirements. How are you balancing heritage protection with innovation?
It's a fascinating challenge. London operates under a complex regulatory framework that includes 38 conservation areas, thousands of listed buildings, and protected viewsheds of landmarks like St. Paul's Cathedral. We've had to develop what we call Heritage Impact Assessment Protocols, specifically for aerial mobility infrastructure. These evaluate not just physical impacts, but also visual, auditory, and experiential effects on historic environments. For example, any vertiport visible from a Grade 1 listed building must undergo an enhanced design review process. We're also establishing acoustic conservation zones around particularly sensitive sites like Westminster Abbey, where vehicles must operate in reduced noise modes. The public acceptance piece is interesting in London. There's both resistance and a certain pragmatism. Londoners have seen transportation evolve from Roman roads to underground tunnels to elevated railways. There's a recognition that the city must continue to adapt. Our research shows that approval ratings for aerial mobility increase significantly when it's framed as reducing ground congestion and returning historic streets to pedestrians. When we demonstrate how aerial transit might allow us to reduce street width and expand pedestrian areas in places like Oxford Street, public support jumps by more than 30 percentage points.
Let's discuss specific infrastructure adaptations. Dr. Lin, Singapore is already constructing dedicated vertiport facilities. Can you tell us about their design and integration with existing infrastructure?
We're currently developing 3 categories of aerial mobility infrastructure. First are primary vertiports, comprehensive facilities at major transportation hubs like Changi Airport and central MRT interchanges. These include multiple landing pads, passenger processing facilities, maintenance areas, and energy infrastructure. Second are neighbourhood skyports, smaller-scale facilities typically located on the rooftops of existing neighbourhood centres or integrated into new HDB developments. These serve as local distribution points, similar to bus interchanges. Third are what we call micro-landing zones, minimal infrastructure landing points for emergency services, priority deliveries, or on-demand services in areas with limited ground accessibility. What's unique about our approach is the integration with energy systems. Each landing facility incorporates renewable energy generation, typically solar, and battery storage systems. In some cases, aerial vehicles can actually contribute to our distributed energy network by providing mobile battery capacity. We're also retrofitting existing infrastructure. For example, we've modified the roof of the Marina Bay Sands complex to accommodate a 12-pad vertiport that will be operational by next year.
Carlos, Los Angeles has extensive existing transportation infrastructure. How are you adapting it for aerial mobility?
Our approach is to maximize existing assets wherever possible. For example, we're piloting a program to convert the top levels of public parking structures into landing facilities. These structures already have the necessary structural capacity and are typically located near commercial centers. We're also exploring what we call mobility hubs, integrated facilities where passengers can seamlessly transfer between ground transit, ride-sharing services, and aerial mobility options. Union Station downtown will be our first comprehensive mobility hub, with construction beginning next year. One unique aspect of our approach is the freeway cap vertiport concept. We're identifying locations where we can build platforms over existing freeways to create new public spaces with aerial mobility facilities above. This reclaims land that was effectively lost to communities when freeways were constructed and creates new connection points. We're also working with commercial property owners. The revised Los Angeles Aerial Mobility Incentive Program provides density bonuses for new developments that incorporate public vertiport facilities. Several major projects under development in downtown and West LA have already incorporated these features.
Dr. Harrington, London's infrastructure challenges seem particularly complex. How are you addressing them?
We're taking a nuanced approach that respects London's layered history while enabling future mobility. We've identified three primary infrastructure strategies. First is adaptive reuse of existing transportation structures. For example, we're converting portions of Battersea and Waterloo rail stations to incorporate aerial mobility facilities while preserving their historic character. The Victorian railways transformed London. We're now adding another layer to that legacy. Second is the invisible infrastructure approach, developing systems that enable aerial mobility without visibly altering the urban landscape. This includes underground passenger processing facilities and mechanized systems that allow landing pads to be concealed when not in use. Third is what we call Thames utilization, leveraging the river as a natural aerial corridor with floating or riverside landing facilities. The Thames has always been London's primary transportation artery. This is simply its newest manifestation. One specific project I'm particularly excited about is at Canary Wharf. We're developing a multi-level mobility interchange where the underground, DLR, river services and aerial mobility all converge in a facility that's integrated into the existing built environment. We're also introducing what we call heritage enhancement requirements, where new aerial mobility infrastructure must actively contribute to the preservation or enhancement of historic structures. For instance, landing facilities incorporated into historic power stations or market buildings can provide funding streams for their maintenance.
Each of your approaches shows thoughtful adaptation to your specific urban contexts. Let's turn to community impacts. Carlos, Los Angeles communities have historical reasons to be skeptical of transportation infrastructure, given how freeways divided neighborhoods in the past. How are you addressing equity concerns with aerial mobility?
That's a critically important point. The legacy of freeway construction through predominantly minority neighborhoods is something we must acknowledge and learn from. We've established three core principles for equitable aerial mobility implementation. First is meaningful community participation. Every proposed vertiport location undergoes a community planning process, not just a public hearing. Local residents help shape how facilities are designed, operated, and integrated into neighborhoods. Second is distributional equity. We're requiring that aerial mobility services are available throughout the city, not just in affluent areas. Our initial network includes facilities in South LA, East LA, and the Valley, not just the West Side and downtown. Third is accessibility. We're establishing subsidy programs to ensure that aerial mobility options aren't exclusively high-end services. For example, emergency medical transport via air will be covered by our county health program, regardless of a patient's ability to pay. We're also exploring community ownership models. In several neighborhoods, we're piloting community benefit districts that will share in the revenue generated by local vertiport facilities.
Dr. Lin, Singapore has a strong tradition of top-down planning. How are you incorporating community perspectives into your implementation?
While Singapore does have centralized planning, we've learned that community buy-in is essential for successful implementation. Our Sky Neighbours program that I mentioned earlier is just one component of a broader engagement strategy. We've established neighbourhood aerial mobility advisory committees in each planning district where vertiports are proposed. These committees include residents, business owners, and community organisations who help shape local implementation. We're also addressing specific community concerns proactively. For example, privacy emerged as a major concern in our public consultations. In response, we've established privacy protection zones around residential areas where aerial vehicles must maintain minimum altitudes and cannot hover. Noise mitigation is another priority. We've developed the Urban Sound Comfort Standards specifically for aerial mobility, with tiered acceptable noise levels based on time of day and location. These standards have actually driven technological innovation as vehicle manufacturers work to meet them. Finally, we're focusing on inclusive benefits. Every Singaporean neighbourhood will have access to emergency aerial medical services regardless of income level, and our public transit integration ensures that aerial mobility isn't limited to premium services.
Dr. Harrington, London's communities range from some of the wealthiest neighborhoods in Europe to areas of significant deprivation. How are you balancing these diverse needs?
That diversity is indeed central to our planning. London has a stark east-west divide in terms of economic opportunity, and we're determined not to reinforce that disparity. We've developed the London Access Framework, which establishes minimum service levels for aerial mobility across all boroughs. This ensures that infrastructure and services aren't concentrated exclusively in affluent areas. We're also emphasising public service applications first. Our initial implementation focuses on emergency services, NHS medical transport, and logistics support for essential services. This helps demonstrate the broad public benefit before private commercial services scale up. Community ownership is another key element. We're working with borough councils to establish community air mobility trusts that will have ownership stakes in local infrastructure. This ensures that the economic benefits flow back to communities. Noise and visual impact have been primary concerns in our consultations, particularly in residential conservation areas. We've responded with tranquility preservation zones, where stricter operational parameters apply, including curfew hours and approach path restrictions. Perhaps most importantly, we're linking aerial mobility to broader community benefits. In areas where vertiports are established, developers must contribute to affordable housing, public space improvements, and community facilities through expanded Section 106 agreements.
You've all outlined thoughtful approaches to the complex challenges of urban integration. Let's conclude by looking at timelines. Carlos, when will Los Angeles residents start seeing visible changes to their city as a result of aerial mobility implementation?
The changes are already beginning, though subtly. Several downtown developments under construction now include rooftop infrastructure designed for future aerial mobility, even if it's not immediately activated. Our first public vertiport will open at Union Station by the end of next year, initially serving emergency services and limited commercial demonstration flights. By 2027, we expect to have 5 major mobility hubs operational across the city. The most visible changes will likely come in phases. Phase 1, already underway, involves infrastructure preparation, retrofitting existing structures, and establishing regulatory frameworks. Phase 2, beginning next year, introduces limited operations in specific corridors. Phase 3, projected for 2028-2030, expands to a functional network across the metropolitan area. We're actually leveraging the 2028 Olympics as a catalyst. The LA 28 Mobility Plan includes aerial components for emergency services, logistics, and limited passenger transport, creating a natural deadline for core infrastructure implementation.
Dr. Lin, Singapore tends to move quickly once decisions are made. What's your implementation timeline?
We're already in active implementation. Our first neighbourhood skyport opened last month at Punggol Digital District, currently supporting package delivery services and emergency response. The Marina Bay Sands vertiport I mentioned earlier will begin passenger operations next year, initially connecting to Changi Airport and the Jurong Lake District. By 2026, we expect to have 12 operational vertiports across the island, supporting a mixed-use network of emergency services, logistics, and limited passenger operations. Our Full Sky City 2035 vision unfolds in 3 phases. The foundation phase, 2023-2026, establishing core infrastructure. The expansion phase, 2027-2030, creating a comprehensive network. And the integration phase, 2031-2035, where aerial mobility becomes fully normalized within our transportation ecosystem. What's unique about our timeline is that we're implementing multiple applications simultaneously rather than sequentially. Emergency services, logistics, and passenger transport are all advancing in parallel, each with dedicated infrastructure and regulatory frameworks.
Dr. Harrington, how is London's timeline different, given the complexities of working with historic infrastructure?
Our approach is necessarily more incremental and site-specific. We're currently in what we call the Pathfinder phase, 2023-2025, where we're establishing initial capabilities at 4 key locations: Heathrow, the Royal Docks, Battersea, and the Olympic Park in Stratford. These Pathfinder locations were selected specifically because they avoid the most sensitive historic areas while still providing meaningful connectivity. They're also all areas of ongoing regeneration, where aerial infrastructure can be integrated into developments already underway. The network development phase, 2026-2029, will expand to approximately 15 locations, including more challenging integrations with existing transport hubs like Victoria and Liverpool Street. The mature network phase, 2030 onwards, will see the system expand to approximately 30 locations across Greater London, including more complex implementations in historically sensitive areas. Unlike Singapore or even Los Angeles, we don't envision aerial mobility ever becoming the dominant transport mode in central London. The ancient core of the city will continue to prioritise pedestrian movement and ground transport, with aerial options primarily serving connections to and between outer districts. One interesting aspect of our timeline is that we expect temporary or pop-up vertiports to precede permanent infrastructure in many locations. These allow us to test operations and community impacts before making substantial physical changes to the urban fabric.
Thank you all for sharing your insights. It's fascinating to see how 3 different urban environments are approaching the same technological shift through unique lenses shaped by their specific contexts. Dr. Lin, any final thoughts on what other cities might learn from Singapore's approach?
I'd emphasise the importance of integrated planning, not treating aerial mobility as separate from existing transportation networks, but as an extension of them. The technology is important, but the systems integration is what will ultimately determine success.
Carlos, what would you want planners in other cities to take from Los Angeles's experience?
Don't underestimate the community engagement component. The technology and infrastructure are challenging, but ensuring equitable implementation and community benefits may be even more complex. Start that process early and make it substantive, not performative.
And Dr. Harrington, any closing advice from London's perspective?
Embrace the constraints of your city as design opportunities, not obstacles. London's complex urban fabric has forced us to be more creative in our implementation, likely resulting in better solutions than if we'd started with a blank slate. And remember that cities are ultimately about people, not technology. Keep the human experience at the center of your planning.
Excellent points from all of you. In our next episode, we'll shift from the urban planning perspective to the human experience, exploring how everyday citizens will interact with integrated mobility systems and how these systems are being designed with the user journey in mind. I'd like to thank our guests, Dr. Lin Mei Hua from Singapore, Carlos Ramirez from Los Angeles, and Dr. Elizabeth Harrington from London, for sharing their expertise and vision. If you're interested in learning more about urban planning for integrated mobility, visit our show notes for links to each city's aerial mobility plans, upcoming public consultations, and opportunities to get involved in your own community. Have questions or suggestions for future episodes? Submit them through the Airdrop's Punch community portal or via social media with the hashtag #OnePunchlinePodcast. This is Punch, your guide to the mobility revolution. Until next time, whether in the skies or on the streets,